All right, this is a bit of a reminder. Because I do get emails about when's the quiz, what's the quiz on? We turn our homework with the quiz, is a homework due? And it actually wasn't for any of you guys. Mostly this time. At the beginning of every class, I kind of come over here and do my little spiel in front of the calendar for the next couple of weeks, which is usually at the beginning of the video on YouTube. So if there's ever any question, because trying to respond to the same question on emails is, I try not to. I always worry that I'm going to say something in writing that's going to come back and bite me because I sound sarcastic, and I really don't mean to. But that's why we record. So we're going to finish up chapter 4 today. We're going to get the review sheet today. It's going to post today. The review sheet is not necessarily like your test. It's completely different, or it's not set up like your test. I will show you what your test will look like. But it's a lot more questions than what your test is because it's a lot of practice. If I only gave you as many questions as your test is, it wouldn't be enough practice. You want to see all sorts of different kinds of problems. Okay? If there's anything left to finish on Wednesday, we will. The quiz is Wednesday. There will be no quiz prep posted. We will do the quiz prep at 10 o'clock. Basically, your quiz is going to be some homework questions from 4.1 and 14. Okay? I'm going to write them on the board. I'm not going to print them out. Not going to hand them out. I'm going to put them up on the board. Yeah, like the good old days. Take out a piece of paper, put your name on it, write down the problems, and turn them in when you're done. I'm going to give you like about 10, 15 minutes. 15 at the absolute most. But like the good old days. So we'll do a couple of practice problems at the beginning of class, and at the end of class, take out a piece of paper, put your first and last name on it, and then we'll write them on the board, do it. 4.1 to 4.2, that's it. Last quiz of the year. Today, you'll get something called the final focus that we'll post. Oh, actually, I'm sorry, that's Wednesday. Final focus that we'll post. There is, it's if you want to call it a review sheet for the final, fine. But it's not necessarily a review sheet for the final. It's just, here's a bunch of multiple choice questions covering everything we did this semester. Multiple choice, just so you have something to kind of practice multiple choice wise. I pointed out to the co-rec students, there's certainly a way to do multiple choice tests without actually doing the problem. When you do a multiple choice test, you're going to do it on Scantron. You do not have to show the work. You can write on the test all you want. I will provide scratch paper in case you need to write something on a piece of paper. I will provide it. You don't get to provide. I will provide it. You turn it in with your test. I control everything because that's what finals are all about, is making sure that it's an even playing field for everybody. But work is not going to be checked. It's just, you know, run it through a machine and whatever you get is what you get. How many questions? I don't know. I haven't written it yet. It's going to cover all, you know, the entire semester. I'll tell you right now, it won't be more than 100. It won't be more than, well, I'm saying it won't be more than 50. It won't be more than, probably won't be more than 40. It won't be more than 40. Okay, definitely. So that'll closer to the weekend. Next Monday is just review. Next Monday is December. Review whatever you want to go over, whether it's the chapter 3-4 review sheet or the chapter 3-4 called the final focus. You got to be specific. You have to have tried it. When I say, what do you want to see? You have to be specific because that's your chance, because Wednesday is chapter 3-4 test. Now in the co-rec, if you want to come to 8:30 and ask all the questions you want to ask, that's what we're doing in the co-rec next Monday and Wednesday. Whether you want to ask chapter 3-4 questions or final focus questions. The final itself is December 8th, the following Monday. So it's the 10th. Must be the 10th. I'm all the 10th. 9th. 2 plus 7 is 9. Wow. Correct? Monday the 9th? Okay. The 9th. So at 10 o'clock, same as our regular class time. The co-rec does not meet. So there's no attendance taken or anything like that. That is the last day we meet as a class. You do not come on Wednesday. There's no class here. You come to it's called a final. So that's it. All right. So the last day we meet is Monday the 9th at 10 o'clock. The final goes from 10 to 11:50. You have nothing to turn in. There's no homework due that day or anything. It's just the final. I'm not giving back the chapter 3-4 tests. I keep those. Okay. How will you know what you got? We'll talk about that later. I don't have enough room to write it down. Okay. You will need a Scantron 8A2-E and a number 2 pencil, and definitely a calculator. Where do you get those? You get those in the bookstore. There's a machine down there in the lounge, a couple doors down. But you need that Scantron 8A2-E. She has a lot of them, $1.50 each. Okay. Supply that. But any questions? But during that time, yes, there's no co-rec that morning, but it's just office hours now. So from 7:30 to 9:30, it's just an office hour, office 2 hours. Okay. My regular office hour starts at 7:30, so I'll just keep on going till 9:30. Now, at 9:30, it ends because I want to make sure everything is ready to go for the final. Okay. Co-rec, we don't. Last day of co-rec would be the 4th. Any questions? Okay. Rules of exponents. What we're going to do today. What we did last week. We got log form, log base b of double division x there. Log base b of x equals y. Converts into exponential. Base to the across, b to the y equals what's inside x. Common log is base 10. So the way you write a common log, you won't always see a 10. So it's the only LOG, only logarithm that doesn't have a number down here as the base. So if you see LOG and no base, it's a base 10. Sometimes it will write it with a 10. So then it's still common log, it's a base 10. So when you see this, it's just 10 to the y equals x. Ln is the natural logarithm. It's base e, the natural base, the number e. Approximately 2.71828. E to the y. There's an e down here. Base e to the y equals what's inside x. Base to the across equals what's inside. That's how we convert. And we did this over here. that bonus?
Yeah.
Okay. Common log, base 10. Natural log is base E. There's an E down there. Written like this. And then these properties of logarithms. These are the freebies. Any take, no matter what, any logarithm that you take of a 1 is 0. You take a logarithm based whatever of a 1, the answer is 0. Natural log of 1, 0. Log base B of a B. So if the base is B, then what you have here is a B. Log base 2 of 2. Log base 9 of 9. Log base square root 3 of a square root 3. The answer is 1. Log base B of itself is a 1. So the natural log of E, there's an E down here. Log base E of E is 1 because the bases are the same, and that's just E. Log base B of B to the X. Logarithms and exponential functions are inverse functions. They undo each other. So since this is a logarithm base B, and inside you have an exponent base B, this logarithm undoes that exponential function, and it undoes it. You get the X that is the power. You get that X. They undo each other. So if the base of the logarithm is B, and the inside is an exponent base B, we get the X. Same deal here. This logarithm, natural log, is base E. Inside, you have an E to the X. Bases are the same. They undo each other. If it's written as an exponent, the base of the exponent is B raised to a logarithm base B. So B to the power of log base B. They undo each other. You get that inside with the X. E to the natural log of X. Bases are the same. They undo each other. These are the freebies. If I gave you, and I used to just give, what is E to the natural log of 7? And all you have to do, oh, that's 7. It's a done deal. And I get people, they just leave it blank. And they don't know the properties. It's a base E. This logarithm is base E. Since the bases are the same, they undo each other. You recognize the properties, you recognize the answer. 17 to log base 17 of 120. That's an exponent base 17. That's a logarithm base 17. They undo each other. The answer is 120. That's all you have to do is recognize the property. No work. Well, I did the work. There it is. That's all you had to do. Okay. Does anybody like cherry Coke? Or does anybody want this? What cherry Coke machine gave me when I hit Sprite? I hit B4, it gave me B1. It's unopened, so whoever gets here first. If she got it, I guess I had to deliver. How'd she get away with that? Maybe deliver. All right. And then log base B of X equals log base B of what? If the logarithms are equal to each other and they have to be the same base, then the insides have to be equal. X equals Y. Natural log of X equals natural log of Y. Natural log of this equals natural log of that. Then this equals that. The insides are equal. Because in 4.4, we are solving equations. It's time to solve. Okay. We'll check it. Get all of the examples for 4-2. Okay. And then on Wednesday, we will start with examples for the quiz from 4-1, 4-2. So, first off, this is also going to post. All these properties and logarithm, everything I've just kind of gone over. These guys right here that are over here. Okay, so these will post for you. Now over here, there's only 4 of them. That's because I typed those up as number 3 right there. I wrote it up as number 3 and number 4. So I split them up into 2 separate properties. Okay, that's why there's 5. Then the next 3, sum, difference, and power properties for logarithms. That's what we're covering today in 4.3. And then the last ones we have are the change of base properties that we're going to see today. So these last 2 big concepts right here, these are 4.3 concepts. So this will be on the back of, when I give you the review sheet, actually not on the back, it's the 3rd page on the review sheet. Okay, on the back is the solutions. And then speaking of the review looks like this. So it's a lot different. It's not written like the quiz or like the test. So that's a little bit different. I will go over what the test looks like probably on Monday. So we're going to do these properties first, and then we'll go back to do the change of base rules. Algorithms are actually here to make our lives less complicated. And I know that sounds weird. Logarithms actually make all of your operations, multiplication, division, and exponents, one operation simple. Logarithms can change multiplication into an addition problem. Logarithms can change division into a subtraction question, and logarithms change exponents into multiplication. So they take it down one level of operation. Multiplication becomes addition. You add instead of multiply. Division, you subtract instead of having to divide. And then exponents, you can multiply instead of raising it to a power. Okay? It comes incredibly handy when you're trying to do calculus. All of these properties are definitely necessary when you want to do calculus, because you can take a problem of calculus that has 15 steps and cut it down to about 4 if you know your properties of logarithm. I mean, exactly. 8 steps, you cut it down to about 3. So the first one, the product. Log base b of u times b. So you have multiplication in here. We can separate multiplication of product into the sum of the 2 logarithms. You see, back in the really old days, not necessarily when I was, having to survive and live and learn, I was going to school in the age of early calculators. First calculator that I ever used actually didn't really run on batteries. We had to plug it in. when you hit the buttons. If you hit a button too big where I had to do a long calculation, the numbers would kind of roll over to the end and they would circle around and spit out an answer rollovers. Right? And it was all in red and it would heat up if you used it for too long. So that was like in the mid 70s, late 70s. Before that, slide rules, tables, lots and lots of tables. In the back of textbooks, they still have all the tables. So in order to do logarithms, you would look in the back of the table for the values of these logarithms. And if you wanted the log of 15, let's say the common log of 15, there is nothing in the back of the book that has common log of 15. Why do 15? Because you can't have a table value for every single number. We had to remember that this is 3 times 5. So then you have to look up the log of 3 and then add that to the log of 5. You have to split that apart. You figure what times 3 or what times what is 15. And you have to break it down into primes. Then we can figure it. Because there's not going to be a 15. There's not going to be a 6. Log of 6 is not going to be in the table. So you would have to look up log of 2 times 3. So that would be the common log of 2 plus the log of 3. And then add those two decimals together. When you take certain standardized tests, and they say no calculator, they give you those values. They'll give you the decimal for log of 2. They'll give you the decimal for log of 3. They'll give you the decimal for log of 4, log of 5, and then they'll try to confuse you with all these possible answers. Okay? And then you're supposed to add the decimals by hand. But in order to do it, you got to know the properties. Okay? But the bottom line is, if you have a product, log base b of u times b, we can separate multiplication with addition. Log base b of u plus log base b of v. Likewise, if it's a natural log of u times v would be just the natural log of u plus the natural log of v. Why does this work? Rule number 1. If you multiply the same base, you add the exponents. Multiplication, when you have exponents, becomes addition of the exponents. Multiplication, addition of the logarithms. It comes from the same place. Because logarithms and exponents are linked together as inverse functions. That's what it's all about. I almost feel like I'm supposed to do the hokey pokey, but that's what it is all about. Okay? So if multiplication is separated with addition, then division log base b of u over v. Then division can be rewritten as, what do you think? Yeah, subtraction. If we separate multiplication with the addition, we're going to separate division with subtraction. Log base b of the numerator, u, minus log base b of v. You subtract it. Multiplication becomes addition of the two logarithms, and then division, we subtract the two logarithms. Okay? Because if you were going to look up common log, log base 10 of 2/3, there's no 2/3 in the back of a book. So you would have to look up what is the common log of 2 minus the common log of 3. And then you subtract those decimals. If you wanted to look up what is the common log of 0.15, 0.15, 0.15. You don't have to wait because that's doing our rule. So multiplication we split up with addition, and division we split with subtraction. Log base b of u over v is the log of the numerator minus, put the u, minus the log of the denominator, and then the natural log of u over v is the natural log of u minus the natural log of v. On Thursday last week, nobody knew this reference. Drew Carey currently is known as the host of what?
Price is Right.
That Price is Right. On the Price is Right, when they call you to become a contestant on the Price is Right from the audience, what do they ask you to do to be a contestant from the audience? They ask you to come on down. You're the next contestant on The Price is Right. Is anybody familiar with that reference? Come on down. Have you heard it before? Just humor me. Because this next property is a come on down property. It's The Price is Right property. Used to go over really well, 20 years ago, but now it's like, what's the price of the right? What are you talking about? I'm on TikTok at that time. I don't know what you're doing. I was scrolling through the channels that we don't get. Or sorry, scrolling through the channels that I've never seen that we do. There's an actual channel dedicated to the classic Family Feuds from the 1980s. And do you know what the Family Feud is? I think Steve Harvey hosts it now. Back then, the big money, they would win like $97. That was the jackpot. They'd walk away with $280 was the big win for the day. Leave that one there. I wonder if I put my day job and went and try to do nighttime stand-up. I wonder how long it lasts. If we needed to solve 2 to the x equals 6, we do know that 2 squared equals 4, and we know 2 to the third is equal to 8. So a power that equals 6, we don't necessarily have. So trying to figure out 2 to the x is equal to 6, to undo that exponent, we don't divide by 2 because it's not multiplication. So dividing by 2 is not going to work. Adding or subtracting 2, definitely not going to work because it's not, we're not going to do addition, we're not going to do subtraction. To undo an exponent, it's about logarithms. So we got to figure out how to bring that x down. How do we get the x down from its exponent? So here we go. The power rule. Log base b of u to the x power. This x can come on down. It becomes one operation simpler. And this becomes x times log base b of the u. An exponent problem becomes a multiplication problem now. Come on down, it's times. So instead of an exponent, it's now multiplication. That's the power property. We can bring that exponent down in front. Log base b of u to the x power is x times log base b of u, and natural log of u to the x is x times the natural log of u. Exponent becomes a multiplication. Multiplication can be rewritten as addition. Division is written as subtraction. An exponent can be written as multiplication. So when we have this 2 to the x equals 6, and we want to solve that. Well, here's what you could do. I want to undo this, and I want to get a decimal answer. What logarithms does your calculator do? On your calculator, on our calculator, do these two down here. What two bases does our calculator do for logarithms? Base 10 or base e. So what would you rather push, base 10 or base e? Okay. So what I can do is I can take log base 10 of both sides. The common log of both sides. And what happens is, come on down. This is now multiplication. So it's x times log base 10 of 2 equals the common log of 6. Since it's now multiplication, I'm just going to divide both sides by the common log of 2. And so the x that I want to solve for is the common log of 6 divided by the common log of 2. Now, I want you to kind of slow just for a second. I'm going to type each one in one at a time because I want to show you something. And then I'm going to show you what you can do to speed it up. So the common log is 6. I want to show you how important parentheses are. But here's the common log of 6. Enter. So the numerator is 0.778 1512 1512 504 over. Back to this. Then my common log 2 so the denominator is 0.30 10299 299957. And then you divide those two decimals. And we get 2.584 96250. And the directions are going to say on the test, since it's the same as the homework, round to the nearest thousand. So that'd be 3 decimal places. So we would round this to approximately 2.585. Now, how can I simply see if I got this right? 2 to that power is supposed to be a 6. So I can check it if I just do 2 to the last answer in my calculator, 2 to that power, so I go answer. So I don't have to type it in. And see if I get 6. Now, if you notice, I did do the decimals. You don't have to show me these decimals. What I want to see from you is you rewriting it out as log of what over log of what, changing it to this. That's what I want to see. Write that out. You don't have to show me this. You can just punch it up on your calculator and go straight to here. Be careful. Look what happens if you don't put parentheses like you're supposed to. When I typed it in, log of 6 parentheses divided by log of 2 parentheses. Watch what happens if I don't put parentheses. Log of 6 and then just divide. And then log of 2. Completely different problem or question. Just answer. So you got to be really careful about it. And you're going to just write it down because that's the calculator said. Now, you could also do natural log. So I'm trying to solve this. I have to undo that exponent. I take the natural log of both sides. Come on down. So it's x times the natural log of 2 equals the natural log of 6. So to solve multiplication, you divide both sides by the natural log of 2. X is equal to the natural log of 6 divided by the natural log of 2. Here are the decimals, natural log of 6. The natural log of 6 is 1.79, 175, 9469. The natural log of 2 0.69314 71806. When I use base 10, I get 0.778. When I use natural log base E, 1.7917. Their numerators are different numbers because I'm using different bases. But as the numerator changes, so does the denominator. And what that means, if we do it, what that means is the ratios are still going to give you the same answer. Because the answer has to be the same. Whether I use base 10 or base E, the ratio will be the same. So now I just punch it up, natural log 6, divided by 2, parentheses. It has to be the same no matter what. 2.5849. So it doesn't matter which one you punch it up with, just pick one. That's why we have the power problem. Come on down. which basically brings us to the very last part, the change of base. We took this base 2 to the x and we changed them either into base e or we changed it into base 10. You see, here's the rule, or basically here's basically base. Here's the question: 2 to the x equals 6. What is this if you were going to convert it into a logarithm? Because that'll be a question on your quiz on Wednesday. There's the exponent form. What does it look like as a logarithm? How do we convert backwards from base to the across equals what's inside? So what's the base of my logarithm? It's a 2. The base of the exponent is the same as the base of the logarithm. Base to the across. So over here, what's the to the power? So across is base to the across. So base 2 to the x, 2 to the x equals what's inside. Base to the across equals what's inside. So the 6 is what's inside. So the logarithm form is log base 2 of 6 equals x. So what we just did takes us right back into this right here, the last piece, the change of base. Keep erasing the one thing I want to finish up with. What is it? Okay. It was 0.15, right? That's we got the answer. We took log base 10 of both sides, and we ended up with log base 10 of both sides. We ended up with this. Log base 10 of the 6 divided by log base 10 of the 2. And we had this question. X was equal to log base 2 of 6. And when we use the natural log of both sides, we ended up with natural log of 6 divided by the natural log of 2. The change of base rule. I can change this base 2 because my calculator doesn't have a button log base 2. I can change this logarithm base 2 into base 10. It's log base 10 of what's in here, and I divide by log base 10 of that base 2. Log base 10 of the inside divided by log base 10 of the old base. Or natural log of what's inside divided by natural log of the old base. The change of base rule is this. Log base b of x can be rewritten as log base a of what's inside divided by log base a of the old base. I can change it into any base that you can think of, as long as it, is greater than 0 and is not equal to a 1. But we can convert it. It's called the change of base rule because we can change the base. Now, what bases will we probably change it to? The ones that are on the calculator. Primarily, we will change it into common log of what's inside divided by the common log of the old base, because I can punch those buttons and change it into a decimal value. Or Use the natural log. Natural log of what's inside and divide by the natural log of the old base. So 6, 10, 14. And because I know I'm going to forget it. We have more to do with that. So if I had to look up, I don't want any decimals. If I wanted to look up log 0.15. Well, the first thing I would want to do, this is the log of 15 over 100. 15 hundredths. Because you're not going to have decimals in the back of the book. Okay. Now, we can reduce it. This is log base 3 times 5 over 20 times 5. So this is the log of 3 over 20. So we can separate division with subtraction, and we can look up the log of 3 minus the log of 20. But there's not going to be a log of 20, because what's 20? We're going to 5 and 4. So this is going to be the log of 3 minus. Now here's the problem. This is the log of 5 times 4. And if you do this, this is the log of 3 minus log of 5. We split up multiplication with addition. Log of 5 plus the log of 4. That's wrong. Why is it wrong? Why is that going to be wrong? Parentheses. See, it's minus this whole thing. Right now, it's only minus the log of 5. It's going to actually add the log of that 4. It's minus this. Because together they make the log of 20. So you got to keep it together. Now there's one last piece. Log of 4 is not going to be in the back of the book. Because log of 4 is 2 times 2. So you can split it up into the log of 2 plus the log of 2. Or what else is the log of 4? It's 2 to the what? 2 to the second. And so what you would do is you would rewrite this as the log of 3 minus parentheses the log of 5 plus, come on down, 2 times the log of 2. And you'll have to take care of all of that before you look them up. Now, you're gonna have questions on your test that are a little bit like this, not as elaborate, but it's gonna be multiple choice. And when you have multiple choice, the best way to approach it, forget about trying to do the problem. Eliminate the answers. It can't be you. There's no way we did anything that looks like this. If I take this one, and if we were still going to meet in class and we're going to go over this, somebody's going to hit you over the head. I'm going to kick myself because there's no way it should have been this one. I must have been guessing. Don't guess when you do multiple choice. Think them through. I'll just keep my hey, I didn't do it. So let's look at number 6, 10, 14.2. Number 6, common law and natural law, which was the rewrite. So common law and natural law. We actually want to answer increase 9, 4, 22. Four combines. So all you're supposed to do here is rewrite it as a common log and then as an change of base. So common log, part A. Log base 3 of x equals common log of something over common log of something. So what would be in the numerator? X, and what would be down here? 3. So we change the base from base 3 into the common log of what's inside. What's inside goes on the top. The base for bottom stays in the bottom, but it's the common log, base 10 of the base. That's all you do is change this into the common log of 10, common log of x over the common log of 3. Natural log. So log base 3 of x, natural log of what? X over natural log of 3. Then we're supposed to do this, log base A of 4/5, and we're supposed to convert that using base 10, log base 10. Common log. So how do we split up division? Subtract. So this is going to be log base 10 of 4 minus log base 10 of 5. Log of 4 minus log of 5. Now it doesn't say that we have to undo that base 4 or that 4 squared. So, but if you took it further, this is log of 2 squared minus the log of 5. If you were going to show off, it would be 2 times the log of 2 minus the log of 5 if you wanted to show off. But I think that's as far as you're supposed to go right now. And if we convert it with natural log, division is going to be separated with subtraction. It's they just want to change a base. They don't want us to do this. They don't want us to, they don't apologize. They just want to change the base. They don't want the division, which I'm thinking too much into. They want common log of 4/5 over common log of 8. They want natural log of 4/5 divided by the natural log of 8. That's all. Wants a decimal. So what are we going to convert it with? Common log or natural? Common log. Common log. So base 10. Common log of what's inside? Common log of 4 divided by the common log of the old base, common log of the now. I want to see this written out. I want to see this written out, then you can just punch it in. Common log of the 4. And then divide by the common log of the now. Just in case you type it in wrong or whatever, at least I know you converted it correctly. Looks like I just like it like I just typed it in wrong. That's supposed to be done. And then I said round to 3 decimal places. So that 0 becomes a 1. 0.631. On 22, we're supposed to rewrite it just using natural logs of a 4 and natural log of a 5. So we have to convert it into 4 or 5. Well, I see a 5 times 100. But 100, I need to now convert it into a 4 and a 5. Powers of 4, powers of 5, powers of 5. Well, 5 has got 500. So 5 times 100, 5. You got 25 times, you got 5. You have 5 to the third. And then you don't want to break this into 2 times 2 because you want to leave it a 4. 500 is 5 to the third times a 4. You want 5s and 4s according to the directions. So this is the natural log of 5 to the third times 4. So that means it's the natural log of 5 to the third plus the natural log of 4. And then this will come on down, and it's 3 times the natural log of 5 plus the natural log of 4. Rewrite it with a just natural log of 5 and the natural log of 4. So it's in there somewhere. As an exponent, bring down the powers. We have 26. So you're gonna take a short walk in my shoes. Log-based behavior. You're gonna approximate log-based p of 30 to 4 decimals. And all you know is log base b of 2 is equal to 0.3562. Log base b of 3 is equal to 0.5646. And log base b of 5 is 0.8. Here's 71. So what you have to do is convert this into a 2, 3, or 5, or a combination of those. So 30 is 30. Give me two numbers to make 30. 15, 2. No, I don't have anything with a 15, so 15 is 35. So this is log base b of 2 times 3 times 5. Well, I know if you have two things multiplied together, you split it up with addition. What if you have 3? You split them up with addition. This is just log base b of 2 plus log base b of 3 plus log base b of 5. So it's 0.53562 plus 0.5646 plus 0.8271. So yeah, 9, 4, 1.7479. Is that right? Oh, yes. Okay. But that's all you do. You got to figure out how to split this number up into those values, and then you can just add, subtract, multiply, whatever. Of course, like that. Okay. What he says, use properties of logarithms to rewrite and simplify the logarithm expression. Log base 3 of 9 squared times 2 to the 4. So multiplication can be separated with addition. So this is log base 3 of 9 squared plus log base 3 of 2 to the 4th. So this is 4 plus 4 times log base 3 of 2. I'll wait up here. My mom made no credits. No question on that, huh? No questions, and we can move on. 48. I'm trying to be like, secretive or anything, just maybe you might have a question on that. Thanks. I was you one. We're on it. Probably around September. No problem. It's in a lot problem. Yeah, it technically is. This is exactly right. This is 3 squared, isn't it? 9 is 3 squared, and we're squaring it. So this is basically log base 3 of 3 to the 4th. So since the base is 3 and that's 3 to the 4th, I just went this whole thing to the 4th. That's all. But you can bring down, it was 9 squared, bring down, you have 2 times log base 3 of 9, but that base is 3 and that's a power of 3. You got to simplify that a little bit more. Those are the things that I recognize. Can you go further? I can't change 2 into a, 3 to some powers of 2. You can't make 2 a power of 3. So that's as far as this goes. But 9 is a power of 3, so that will go further. It is a property. Good of you pointing that out. Number 48. Use the properties to expand the expression as a sum, difference, or constant multiple power. So that's 48 and 56. So it's log base 10. So because this is multiplication, this would be, and I'll go ahead and I wrote it as with the base of 10 there because that's what how the book wrote. That it would be the common log of the 100 and then plus the common log of the x. And then you got to recognize, just like I did over here with that 9 squared. 9 squared is 3 to the 4th. 100 is a power of 10. This is the common log of 10 to the 2nd. Which if I kept writing that base, if I kept writing, hey, that's a base 10 and that's a base 10, if the bases are the same, they undo each other. So this is just the 2 plus the log of x. Okay. Things you gotta start recognizing. Red means stop, green means go. Yellow means go faster. Okay? I don't say that. Number 56. First thing I see is division. I'm going to split up division with subtraction. So it's these two, the numerator. Keep that together, natural log of x and y, and then minus the natural log of z. And then these two can be split up with addition. The natural log of x plus the natural log of y, and then minus that natural log of z. This time I don't have to put parentheses around my natural log of x plus natural log of y because I'm not subtracting that whole thing. I mean, I can, and it won't hurt, but I don't have to. Before I did because I was subtracting that quantity. Here I'm just subtracting one term, so it's no big deal. Here, that's right, it's going to be fine. Are you also taking note of how quickly some of these questions just go? It's like one of these things like, if you're not taking care of this homework, it's like, how busy are you? Some of you guys, when you look at your grade, if you just had a bump in your homework percentage, how much would that make a difference? What's your grade here on homework? Wow. On 70. Things that you can split apart, you can put back together. So the directions on number 70, use the property of logarithms to condense the expression. So we want to basically collapse it back into its actual property. So if it was split apart with addition, how can I make it back into one logarithm? Multiplication. So if somebody broke it apart with addition, so we can put it back together, natural log of y times z. Done. Make one logarithm out of it. I pointed out the other day, it actually takes longer to write down those questions over there than it does to actually do the problem from 90 to 102. Find the exact value of the logarithm without using a calculator. Log base 6 of 6. What is it? 1. That is property number 2. Log base b. Log base b of a b. If the base is 6 and inside is a 6, then the answer is just a 1. Now here's the deal. Log base b or log base 6 of 6. Let's say you don't remember the property. What's log base 6 of 6? Oh, let's call it x. So then convert it. Base to the across equals what's inside. 6 to what power equals 6? It has to be a 1. Rewrite it, base to the across equals what's inside. Log base 5 of 1 over 125. You got to remember, your powers of 5. 125 is 5 to the
Third.
5 to the third. But because it's a fraction, this is log base 5, 1 over 125. That's 1 over 5 to the third, which means it's log base 5 of 5 to the negative 3. If it's in the denominator, that means it's a negative exponent. So now you have, again, you have rule number 3, log base b of b to the x. The base is 5, inside is base 5, the answer is negative 3. Log base 5 of 1 over 125 equals. If you don't know that rule, and you don't want to convert this or don't see to convert it, 5 to what power, let's call it x, equals what's inside. The only way to solve this is without a calculator is to get a common base. So you need the same base, that's power 5. 1 over 5 to the third. It's not the same base if it's in the denominator, so when you flip it up, we get 5 to the x, that's a 5 to the negative 3. So that's how we get negative 3. And then number 100 is 15. Because what is natural logarithm e to the fifth? The base of a natural logarithm is an e. Inside, you have e to the fifth. So since the base is an e and inside you have an e, it's this rule. Natural log of e to the x. It's the same as this one. The base is e, inside is base e. They undo each other. So that's just 5. Again, that is rule number 3. 3 on the natural logarithm. .4 is just examples. 4.4 is solving all sorts of different kinds of applications with logarithms. And before I get there, I want to point this out. You're going to get an email and as well as to be posted in the announcement. Take a look at the announcement. So announcements for you guys, going to post at 12 today. YouTube delivering lots of how-to and homework examples. Okay. These videos were created during the spring of 2022, so ignore any due date or test date references. All of that is completely outdated. Ignore anything that is said about it. Homework 3A, homework examples. Homework examples for 4.2, for 4.3, and extra homework examples for 4.4. I don't believe they overlap at all. And so there are extra examples that aren't done in here. Okay. So that'll be email and it will also be posted. If you just go to the web page, or the YouTube page, and you go to playlists, you might have to rearrange. I always sort by last video enter, last video added. For me, it's this one with all the little mathematicians, little busts. The right one. Okay. So number 24. Solve the exponential equation. Here's what you're gonna have to do. You're gonna have to remember, chapter 4 is about solving logarithms and exponents. So quadratic formula is not necessarily going to be one of the options, okay, unless it's a bonus question. Three to the x equals 243. 3 over 4. The x is equal to 64 over 14.7. 6. So, x minus 1, 256. Actually, make sure you actually print it or start looking at, maybe start thinking about that. But it's close in. Those are the announcements. They're perfect powers. You're gonna need the same base. 3 to this power equals, you want the same base over here. You can't rewrite the left side as any different base, it's a 3. So if we're gonna solve this, we're gonna need base 3. So it is 243 a power of 3. So looking here, if the base is 3, there, 3 to the 5th is 243. So 3 to the x, 243 is 3 to the 5th. Since the bases are the same, then this x has to equal 5. Rewrite both sides with the same base. Now, could you use logarithms? Yeah, but you shouldn't have to. 3 to the x equals 243. What logarithm would you want to use? Base 10 or natural log? Pick one. Okay. So natural log of both sides. Bring down the power, come on down. X times the natural log of 3 equals the natural log of 243. Now what do I do?
Divide by natural log of 3.
Divide by, because this is multiplication, you divide both sides by the natural log of 3. So if x is equal to the natural log of 243 divided by the natural log of 3. There's 5. Okay. You would have to show your work though. 3/4 to the x equals 64 over 7. Want to get a common base? Well, just so happens 64 is a power of 4. It's 4 to the 3rd. And 27 is a power of 3. It's 3 to the 3rd. So we got something going on here. This is 3/4 to the x power. This is 4 to the third over 3 to the third. The problem is 4 to the third, 4 down here. 3 to the third, 3 is up there. So I can flip this. This is 3/4 to the x. This is 3 to a -3 over 4 to a -3 if I flip it, which means 3/4 to the x, and over here, this is 3/4 to the -3. So x has to equal -3. And it's flipped. The negative will flip it. Very sad. So that x minus 1, it probably is a good idea to have it in a parenthesis, so you know that it's not 4 to the x with a -1. The whole exponent is x minus 1. So rewrite both sides with the same base. I wonder if 256 is it's a power of 4. It's 4 to the 4th power. And the reason why I want to make sure I have that. 4 to the 4th power, because this is base 4. It's going to work out really nice if that's also a base 4. If they're the same base, then I just let the powers equal them. Now, the only other option is maybe it's a base 2, because I can change this to a base 2. So if I have to make a correction, I have to make it correct. But that's a base 4. So you rewrite both sides. That's a base 4. So 4 to the x minus 1. Over here, this is 4 to the 4th power. So this x minus 1 is equal to that 4. Add 1. And x equals 5. Now, what if you don't know? Well, 256. Break it down. That's 2 times 128. So that's 2 times 2 times 64. And you got 2 times 2. If you do it only twos, okay, you got a long way to go. Maybe you start the right here, go 8 times 8. So that's 2 times 2 times. And then you remember, oh yeah, he said this should be 2 times 2 times 2. And that's 2 times 2 times 2. I'm hoping for 4s because this is a 4. There's a 4. There's a 4. There's a 4. And hey, there's another 4. 4 to 4. I'm hoping for 4. I know what to look. Sorry for the pun, but I'm looking for 4. 4, 4. Not 4, 4. I got 4 4s. I don't know how that works. But solving this. I have natural log of x equals the natural log of 2, then guess what? X has to equal 2. If I have 2 logarithms equal to each other, they're the inside type. $44 is hiding up there. 44. The common log is supposed to be common log. So common log of x equals -1/4. We're solving for x. So what's the base?
Okay.
Base to the across equals what's inside. Yes. Now, if they don't want negative exponents, then this x would equal 1/10⁴ power. Things like that. If they want decimals, you punch it in. That's a 1/4. It's 3044. Yeah, I'm gonna just do those two because the other ones, the 56, 62, 98, or 68 are or calculator one's gonna take a little bit longer to punch them in, so we'll do those on Wednesday. There will be YouTubes on those as well. 104, we'll do that on Wednesday as well. But these last two. This one is gonna take this long. Okay with that? Because if we're not telling you. No, don't be shy. Just,
It's a be the second topic, right?
yeah, it's just property, nothing, well, it's not the second one, it's actually the third. Because the natural logarithm is a base e, and inside you have e to the 2x minus 1. That's a base e. Natural log undoes e to the 2x minus 1. Finish 2x minus 1. If you don't know, oh, well, that's an x. Let's call it y. The base down here is e, so e to that y equals what's inside. So this has to equal that, which means this is 2x minus 1. And over here, they're going to want a decimal answer, but we're going to punch it in first. Or sorry, we're going to rewrite it first and then punch it. What's the base of this? So e to the what? -4. Base to the across equals what's inside. So you're just going to punch this in. You're going to hit e to the -4 and then round to 4 decimal places. That's all. So you're going to have that announcement with all the extra YouTubes with extra practices. We'll just finish up those extra practices. Here is the review sheet for chapter 3-4. So you can get a start on it. First thing at 10 o'clock, we will be. You know what? I'm gonna put them over here. You just grab one on your way out. First thing at 10 o'clock will be the quiz prep for the last quiz. See you Wednesday.